Hello everyone, welcome to the tutorial to solve the problems given in the Popquiz. Enjoy it! The figure shows a square ABCD and an equilateral triangle ABE. Find the size of angle CED. So then it will be since ABCD is a square, so all the sides of a square are equals in length, and then each interior angle is 90 degrees. And it is also given that ABE is an equilateral triangle. So then if AB is this long, BE has to be equals to AB as well as EA. So then we are having this interior angle in the triangle EAB is 60 degrees. This interior angle as well, and so with angle E in the triangle AEB. Next, based on the information, I might be cannot find the size of angle CED right away, but then I'll be just using all the informations given to me to be the ways to find the size of angle CED. So let me continue. Here, angle A in the square ABCD is 90. So then if angle A divided into two parts and one of the parts is 60 degrees, so the other part here has to be 30 degrees. And look, the triangle EAB is to be an isosceles triangle. So then the size of each angle equals to the other. So they're equals to each other. And together angle E, angle D, angle A in the triangle EAD add up to make 180 degrees. So then each of this angle, it will be 180 minus 30 divided by 2 for each. So it's gonna be 75. Now move on to triangle BEC. In the triangle BEC, we can see it is also an isosceles triangle with this angle B is 30 degrees. Since B in the square ABCD is 90 degrees, so then if B divided into two parts and one of the parts is 60 degrees, so then the other part is 30 degrees. So then again, angle CBE is 180 degrees. So then angle C here and angle E here in the triangle CEB has to be having the same sizes. So each of them will be 180 minus 30 divided by 2. There we get 75 degrees as well. So then, look, CED, angle CED is an angle at the point E together with angle CEB, angle BEA, angle AED. So then angle CED equals to total 360 degrees minus one part 75, the other part 75, and 60 degrees. So then angle CED equals to 360 minus 75 minus 75, so it has to be minus 150 and minus 60, so minus 210. So 360 minus 210 will be giving me 150 degrees. And yes, it makes sense that CED is 150 degrees since the picture gives me the sign that it has to be an obtuse angle. So yeah, That's angle CE equals to 150 degrees. Question number 5. Given that AB is parallel to DC, find the values of the unknowns in each of the following figures. In figure A, the clue is AB is parallel to DC. And then here we are having an equilateral triangle BAC. So apply the property of equilateral triangle that each interior angle measured 60 degrees. Then let's see from the information given, AB is parallel to DC, and I have to find the value of the unknown A in here. Here, based on the picture, I can identify that BAC is an isosceles triangle. So then, the property of isosceles triangle, there should be two angles with equal size. So then, the two angles will be here. Angle in the base, right? Or we call it base angles, right? And each will be the same to another one. So here has to be A. Now see the angle CAB here. What I can identify that DC is parallel to AB, and I see that CA is a transversal to the parallel lines. And what I see also there, angle DCA is 60 degrees. And I'm sure that angle BAC is also 60 degrees since angle BAC is alternate to DCA. So then here has to be 60 degrees. Next, I am confident with that I can find the size or the value of A. So then A will be equal to 180 degrees minus 2A, right? I meant 180 degrees minus or equals to, I meant 180 degrees equals to 60 degrees plus 2A if we wish to make a question. So then here is going to be 120 degrees equals to 2A degrees, so then A degrees is going to be 60. Okay, I got the value of A. A equals to 60, or A degrees equals to 60 degrees. Next, in figure B, from the clue given here, we just know AB is parallel to DC, and then we need to find the value of B, the value of C, and the value of D. So then what I can identify there, that DC is parallel to AB. And this 76 with these two angles, which is 2B squared, 2B degrees equals to 180 degrees. So then 2B plus 76 degrees equals to 180 degrees because of supplementary angles. Or before you see supplementary angle, we see that it is interior angles. So then 2B degrees equals to 104 degrees. So then B degrees equals to 52 degrees. So that's the value of B, found 52 degrees. Next, the value of C. I'm gonna do similar thing just like I did finding B, but it's with the right hand side of the shape. It will be 180 degrees plus 2c degrees equals to 180 degrees again because of supplementary angles or interior angles. They add up to make 180 degrees. So then 2c degrees equals to 180 minus 118, and it will be 62 degrees, and that's 2c. So c degrees is gonna be 62 degrees divided by 2, it's 31. So then here will be 31, and we got the value of c degrees equals to 31. So then I'm sure, since we found B already, found C already, we will be confident to find the value of D. So B found 52 degrees, C was found 31 degrees, right? So then D degrees, it's going to be 180 minus 52 minus 31, or in brackets I can put them 180 minus brackets 52 degrees plus 31 degrees, and that will be equals to 180 degrees minus 83 degrees. So it will be 97 degrees. That's the value of D delta. So it is 97 degrees. Next, number 5, part C. We are to find the value of E, F, and G. All wings corresponding to 58 degrees because of we're having two parallel lines with one transversal. So here, this angle, which is 58, corresponding to this value F. So then F degrees equals to 58 degrees. And then if it is isosceles trapezium, then we will be having two base angles that must be the same in size as well. So over here it has to be 58 degrees. And you know, if it is an isosceles trapezium, this angle on the top has to be 80 degrees based on the property of the trapeziums that we will be having two pairs of equal angles, right? So then here I'll be having 360 degrees minus 58 degrees minus 58 degrees, and I'll divide it by 2, that is equals to 80 degrees. So then it will be 360 degrees minus this total, it's going to be 116 degrees divided by 2 equals to 80 degrees. Let me use this empty space. I'll be having E degrees equals to 360 degrees minus 116 degrees, so I'll be having 144 divided by 2. So it has to be 112 degrees. I would like to check whether E degrees equals to 112 degrees correct or not. So the way I'm checking is I realize that I'm having two interior angles. I mean two angles, they're interior. So then we're having E degrees plus 58 degrees equals to 180 degrees. So then E degrees equals to 180 minus 58. Then yeah, it is 112 degrees. Yay! I got a value of E, I got a value of F. Now I'm moving to find the value of G. Okay, so let me just use the empty space above here. Right, so that will be G degrees. To find G, we're having triangle EDC there, and then that is an isosceles triangle, and we got one of the angle bases there, 58, so the other one has to be also 58. So then G, it's going to be 180 degrees minus 2 times 2 times 58 degrees, so then it will be 180 degrees minus 116 degrees, so then I'll be having 64 degrees. Let me check. 64, yeah, that makes sense because of this is an acute angle. So I must be having acute angle, and 64 degrees for a value of g degrees is showing less than 90, so it's showing an acute angle as well. So then, yep, I'm done with number 5. I found value of E, found value of F, I found value of G, and we found also the value of D, C, and B, and then we found A as well. So next is number 10. It says that if the sizes of the interior angles of a pentagon, so I get one clue here, it's a pentagon, so it has 5 sides, right? 5 angles, right? Both interior and exterior, I mean each interior and exterior. So then here, if the sizes of the interior angles of a pentagon are this, so then the sum of this, sum of interior angle, it will be n minus 2 times 180, while n is the number of sides or number of interior angles or exterior angles. You know, there are 5, so n equals to 5. So then sum of the interior angles in pentagon has to be 5 minus 2 times 180 degrees, and that will be equals to 3 times 180 degrees. That is 540 degrees. So then the sum of this has to be 540 degrees. So then we'll be having 2x degrees plus 3x degrees plus 4x, right, plus 5x degrees, 6x degrees, that is equals to 540 degrees. And for your information, you can also put this formula next to the equal sign instead of putting 540 degrees. Look fancy if you did it, but I just try to make it simple so then you will understand. Here 2x, 3x, 4x, 5x, 6x together, they add up and make 20x degrees equals to 540 degrees. So then there, x degrees equals to 27 degrees. Is it answering the question? I believe not yet. It's because we are to find the largest interior angle of the pentagon. So the largest one has to be 6 times x, right? So it has to be 6 times 27 degrees, and that will be 42, so 162 degrees. And then don't forget, this is a word problem, so better to make conclusion to show what you are finding for, what you are finding about. So largest interior angle is 162 degrees. That's for number 10. Okay, next is number 13. Find the values of the unknowns in each of the following figures. Similar, but since now is not triangle only, not quadrilateral only, but more than 4-sided shape. And we've got polygon here. And we need to find the value of the unknown. So I found A here, and then there are B's there. So I need to find the value of B. So there we go. We're having, let me try to solve A first, right? So then A it is gonna be a pentagon. 1, 2, 3, 4, 5 sides. 1, 2, 3, 4, 5 interior angles. So then, at first I have no idea, but then I just work with whatever I have. There, first is here. I can find the size of this angle because this angle is supplementary to the 62 degrees, so it has to be 180 degrees minus 62, so I'll be having 118 degrees. The other one is this ABC is also a supplementary angle, so angle B here supplement to 112, I'll be having a 68 there, acute angle. Now to get this angle, I have a way. All I need to find first is get the angle in here, the size of the angle, then find the supplementary to that angle. So then let's find the size of this angle. As I said, it's a pentagon, so n equals to 5. Sum of interior angles, right, equals to 5 times 2 times 180 degrees, and that is 540 degrees. So then the total of these interior angles has to be 540 degrees. So then I start to calculate. Let's say that is m that I'm to find first. M degrees equals to 540 degrees minus everything here, 118 degrees minus 114 degrees minus 68 degrees minus 95 degrees. So then m degrees equals, God, we found it. We found this angle, the size is 145. So then, yay, get the value of A confidently. It must be 180 minus 145 degrees, so it has to be 35 degrees. We got the value of A. That's for figure A. The letter A found, that is equals to 35 degrees. Right, now in figure B, I have to find the value of B. But this time, seems that it is, an exterior angle, and this is exterior angle as well. This is also exterior angle. This is also an exterior angle. So let me check. 1, 2, 3, 4, 5, 6. Yep, 6, and then 1 interior, 2, 3, right, 4, 5, 6. Oh yeah, this is a hexagon. So then it has 6 angles, interior, exterior each, and then 6 sides as well. So n equals to 6. And since it's talking about the sum of exterior angles, so I'm going to recall the property of the sum of exterior angle. It will be 360, that's it, for any polygon. So then the total of these exterior angles will be 360. Luckily, we've got all B, so then we're having 2B, all in B, right? Plus 3B, plus 4B, plus, that's all, 1, 2, 3, 4, 5, 6, right? And this is equals to, let me just put the equal here, 360 degrees. So 360 degrees equals to how many B's we have there? 2B, 3B's, right? And then plus another 3B's. So let's say this is 3B's, this is 3B's, this is 4B's, so 10B's plus 2B's here. So then there are 12 B's. So then B degree equals to 360 divided by 12 will be 30. So B degrees equals to 30 degrees. Yay, we found B. So then 3b is gonna be 90 degrees, right? So then c will be supplement to 90. So c will be also 90 degrees. That's value of b, that's value of c. Right, next. Alright, so this is the last question. The diagram shows a regular hexagon and a regular decagon. 1, 2, 3, 4, 5, 6. Okay, so this is the hexagon. So n equals to 5. And this is decagon. This must be decagon, right? N equals to 10. Calculate the value of x. I don't think it's gonna be hard. I'll be applying the each interior angle property. So if the total interior angles of a polygon will be n minus 2 times 180, so each interior angle of the polygon will be divided by the number of the interior angles that the polygon has. So that's going to be that formula. So then let's start with the hexagon. If it is a hexagon, if n equals to 6, right? So then it will be n equals to 6. So then it will be 6 minus 2 times 180 degrees divided by 6. So it is 4 times 180 degrees divided by 6. This each will be 120 degrees. So here 120 degrees. This is also 120 degrees, and so on for the rest. So each interior angle measured 120 degrees. Next, about the decagon, it has to be n. But since n is then about the decagon, the size of each interior angle equals to 10. 10, okay, so here times 180 degrees and divided to 10. So it will be 8 times 80 degrees, so it's gonna be 4 6, so it will be 144 degrees. So each is going to be 144 degrees. So this is going to be 144 degrees as well. So then x together with 144 degrees with this angle 120 degrees is angle at a point. So then x degrees equals to 360 degrees minus 144 degrees minus 120 degrees. Or if I want to do it mentally, I'll be adding this up first. And I'll be having 360 degrees minus the sum of this, it will be 264 degrees. So then here it is going to be 96. Wait, it's not. It has to be an obtuse angle. But let me check it again. So it's gonna be 6 and then it's 9. Yeah, I was correct. X equals to 96 degrees. So then we've got the value of x already. It's 96 degrees. So that is all about the tutorial how to answer problems or how to solve the problems given about angle properties. Hopefully it is useful. And if you have questions, kindly please private comment, okay, and then I'll reach you back through the private comment as well. Thank you very much everyone. Happy weekend. God bless you.